So this is spring 2021 Math 117 problem set 3. Just thought I'd give you a little bit of indication on how to get started on these questions. So for question number 1, we're dealing with a quadratic, and we have a function given to us here. X is the horizontal distance from the start, and h of x, the output, is the height of the shot put. So this is a women's track team. So overall, when we graph this, we're going to get, it's a negative on the quadratic, so it's going to open downwards, and we'll get something that's going to look like that. Okay, so question the A part wants us to plug in 24. We could just plug in the 24 for x, figure out what h is, which will be the y value. So, and again, that's when the shot put is out here at 24 feet. What is its height? So it's kind of helping you out a little bit with the context of the problem. That's what you're going to explain. The x is always how far in front horizontally. The y, horizontal distance, and y is going to be the vertical distance. H of x, right? That's the output value. So you get your coordinates here. The numerical value of the vertical intercept, that is the point when x equals 0. So that's the y-intercept. So when x equals 0, how high is it? And what does that mean? Okay, well, you know how far in front of the person it is, it's 0 feet. Okay, the numerical values of the vertex of the coordinates. So again, using a graphing calculator, you can use that tool to find its vertex, which would be here. You'll get an x value, a y value. What is the x value? It's how far in front. What is the y value? It's how high it is at that time. Okay, so that's what that meaning is, and as you can see, it would be a maximum. And then how far from the start did it hit the ground? Well, when is it going to hit the ground? Well, it's an x-intercept, right? It hits the ground over here. The ground is the x-axis. So once you get this other x-intercept here, again, y equals 0 is the ground. And then you'll be able to explain what x and y are in those terms. For question number 2, we've got Singh getting a base salary. So that means he gets paid $2,200 a month every month. But he also gets commission, but he doesn't start to get commission until he has $40,000 in total sales. He gets 5% commission on the amount over $40,000. Okay, so if we're going to let S be the amount of sales, he doesn't start getting commission until $40,000. One of the best ways to really represent this then is as a piecewise function. Okay, so there'll be a piece here for when the sales are, well, obviously your sales should be greater than 0. I guess you could have some returns and such, but sales should be greater than 0, greater than or equal to 0, and less than or equal to 40,000. Okay, and then for that, he's or she is just going to get, they are just going to get the base salary. So I'll let you figure out what that is. They just get paid that, right? Fixed, y equals that. As soon as his sales exceed 40,000, so when sales are greater than 40,000, then he starts getting commission. So he gets the base salary, still gets that, plus he gets a commission, 5% of the amount above. He still doesn't get 5% of the first 40,000. right? So the way you want to represent that is whatever the sales are minus 40,000. Okay, and then multiply that by 5%. So that's going to be the addition he starts making. And again, here we want to see what happens between $0 of sales and $100,000 of sales. Again, S is our going to be like our X value, it's our input. G of S or the salary is going to be the Y values. And again, you want to have at least from 0 to 100,000 down here, and you want to show what's happening. Okay, we know at 40,000. Well, this is salary. This is dollars. This is sales, which is also dollars. But something happens when reaching 40,000. So there's going to be something happening at this point, and then what happens afterwards. So try giving that a thought. For number 3, again, we've got a rational function, which is a fractional function here. T can be various things. We want to find out the horizontal asymptote. So this means T way into the future. Remember, a horizontal asymptote, whenever you have a rational function, 2x to the third plus 4x, 5x to the third minus 6. The only thing for the horizontal asymptote, the thing that's important are the terms with the biggest degree. So at the top and the bottom, when the degrees are equal, as in this case x to the third, then the horizontal asymptote is going to be a horizontal line at y equals the ratio of the top over the bottom, right? So this is 2/5 because the thirds cancel, the x to the thirds cancel. So that's kind of what you're looking for. Again, we've got a different function up here, but that's the thought process that's going to go in here. You horizontal asymptotes, and remember, if the bottom was the degree was larger, say this was x to the fourth, then the horizontal asymptote would be 0. But then try to think about what that means in terms of the leg. If you want, you can again graph this and see what happens, and you'll see that whatever that horizontal asymptote is, you'll see it on the graph. Okay, and kind of explain that out. So that's hopefully enough to get you started. Keep making progress with your Alex topics. Test 3 deadlines coming up fairly soon, another week, and then we've got the final exam in courses ending up in about 3 weeks. So keep up the good progress and let me know if you have any questions. Thanks.